Yo, 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 yo. Hey, everybody. Thanks for tuning in. We're going to talk about one-step equations. So this is review. Okay, so I'm just want to get that out of the way. This is definitely a review from the most basic part about equations. So the goal of this video is not to be able to tell me what the answer is. Okay, because a lot of these answers are going to be really easy to see without doing any work. So the goal of this video is not to be able to tell me the answer, but it's more about understanding the process of how to get to the answer. This is review from 6th and 7th grade equations, mostly 6th grade equations. And our goal, though, is to understand the process for solving them so that we can use those to solve much more complicated equations. Because as the more complicated equations get, the steps stay the exact same. So if we can master the steps with one-step equations, it'll be a lot easier to move on to 3, 4, 5-step equations. So key terms, inverse operations, integers. Integers are just whole numbers, but it's also negative versions of those whole numbers. So, but no decimals or anything like that. Inverse operations is the opposite, so we can cancel each other out. So addition and subtraction are inverse operations. Multiplication, division are also inverse operations. So what we're going to be doing is we're going to be solving equations. Now, when solving equations, our goal is always to get the variable by itself. Okay, that's what I'm trying to do. I'm trying to figure out what value for x makes this a true statement, makes the left side and the right side equal to one another. So this is a part where I was saying, like, with simple equations like this, a lot of people can recognize, well, 8 plus 7 equals 15, so they can just tell me x equals 8. And that's really great. That I think that mental math aspect is super important. However, what I care about more right now is knowing how to get to x equals 8 if we don't know how to do the mental math, and knowing the process to get there, because that process is going to help us out when we move to more complicated equations in a week. So the way we get our variable by itself is we want to cancel out everything that's on that same side of the variable. So I have this plus 7 over here on the same side of the equal sign. Whenever I talk about sides, I'm always talking about sides of the equal sign. So sometimes what people do is they draw a line through the equal sign. That kind of helps them recognize the left side and the right side. So because I have plus 7, I want to do the opposite, which is minus 7. This is an inverse operation. Okay, so I'm doing the opposite because 7 minus 7 cancels each other out. It makes 0. But the big rule with equations is whatever we do on one side of the equal sign, we have to do on the other side. So because I did minus 7 on the left, I also have to do minus 7 on the right. This maintains balance on both sides. That equals 0, so they cancel out. I bring down my variable because I haven't done anything with that yet. So I got to bring down my variable, bring down that equal sign. 15 minus 7 is 8. And I'm done. 15x equals 8. So this would be my final answer. X equals 8. Okay, so then going over here to the second one, m minus 12 equals 28. Same process, but now I got to look at, okay, I want to get m by itself, so I got to work on the left side of the equal sign here. And if I want to get m by itself, I have to do the opposite of whatever's happening on this side. Well, I have minus 12, so in order to get rid of minus 12, I need to do the opposite, which is plus 12. And whatever I do on one side of the equal sign, I have to do on the other side of the equal sign. Negative 12 plus 12, the reason why we do the opposites is it makes them go away. They cancel each other out because that makes 0. I have to bring down my variable. I have to bring down that equal sign. 28 plus 12, now I actually have to do some math. 28 plus 12 is 40. So m equals 40. 40 minus 12 is 28. Here's what I want you guys to do. Yes, these are negative signs over here. But because they're negatives, it doesn't change anything. We still have to do the math. So we have to follow our rules for integer. So if you can, try these ones on your own. See how you do. But try showing the steps. Everybody's work should look exactly like this. So pause it if you haven't. Try them. Okay. So I want to get my y by itself. So I'm going to get rid of the minus 15 by adding 15. And I want to add 15 to both sides because that makes that go away. I got to bring down my variable, which is y. I have to bring down that equal sign. Now I have negative 27 plus 15. Negative 27 plus 15 is not 42. Okay, so this is where we have to follow our rules with positive and negative numbers. If I have negatives and I'm adding a bunch of positives to it, I'm really doing subtraction and keeping the sign of the larger number. So because I have different signs, I have negatives and positives, I'm subtracting, keep the sign of the larger number. So I have more negatives than positives, so my answer is negative. And I need to do 27 minus 15, which is 12. So my final answer is y equals negative 12. The way we check to see if this answer is correct is I can plug that back in for y in my initial equation. So I can do negative 12 minus 15 and see, does that actually equal negative 27? So I can check my work by doing this. Now, when I do this, I have 12 negatives, I have 15 negatives. If I combine those, I have a total of 27 negatives. So that is the correct answer. I didn't mess it up. I did it right, and I'm done. Now for this last one over here, I have n plus 27 equals negative 42. So I need to do the opposite, which is minus 27. Because 27 minus 27 is 0. I then have to bring down my variable. So n equals, and then I have negative 42 minus 27. If I need to do the work off to the side, I can do the work off to the side just so I don't mess up my equation work. So I need to rewrite it, negative 42 minus 27. I can rewrite it over here. And this is where I got to look at my integers. I have 42 negatives. I have 27 negatives. That's a lot of negatives right there. Okay, so really I'm going to combine these because I have the same sign. I'm combining these, keeping my sign. 42 and 27 does make negative 69. And I'm done. Okay, so moving on. Now we're going to look at ones with multiplication and division. And we're still going to use our inverse operations. So 4x equals 44. So again, a lot of people can realize that x is 11. That's great, but we want to know how to get there. So this, when you see 4x like this is 4 times x. Whenever there's a variable attached to a number, that means multiplication. So this is 4 times x. So what I want to do is we're still doing the same thing on both sides of the equal sign. That doesn't change. But what I'm looking at is what operation is this? This is multiplication, so I want to do the opposite. The opposite of multiplication is division. And we show division by writing down a fraction. 4 times x, I'm trying to cancel out times 4 here. The way I cancel out times 4 is I divide by 4. And whatever I do on one side of the equal sign, I have to do on the other side. Because 4 over 4 makes 1, and there's no point in writing 1 in front of x. That's just 1 times x. Well, 1 times x is x. So that's why they cancel. So it gives me just x, bring down my equal sign, and then I got to do 44 divided by 4, which is 11. So I get x equals 11. Now, if I'm looking at this division one down here, this is a fraction. Every fraction is a division problem. So this is y divided by 8. So the way I cancel out division is I do the opposite. Because this is divided by 8, I want to do the opposite, which is times 8. The opposite of divided by 8 is times 8. So I'm going to show that in parentheses as times 8. And the reason why is these cancel. But whatever I do on one side, I have to do on the other. So I got to multiply both sides by 8. And that's going to give me 32. 32, if I were to plug 32 back in for y here, 32 divided by 8 is 4. And that's why that worked out. Okay, go ahead and pause and try these last two over here. Yes, there's negatives. It doesn't change anything. So pause, try it, see how you do. Okay, so remember, I'm looking for the work here. Okay, the process is way more important than the answer. So I'm looking for work more than anything. Now, this is multiplication, so the way I cancel out multiplication is I do division. So I have to divide both sides by negative 5. Divide both sides by negative 5 to make those go away. Notice I'm showing that they cancel, because that's showing my work, showing what goes away. This x hasn't gone away, so I'm bringing that down. Positive divided by negative is negative. 40 divided by 5 is 8. So negative 5 times negative 8 will give me positive 40. Finally, here I have division. So the way I show my work when I have m divided by negative 6, I want to show multiplication by timesing by negative 6. And whatever I do on one side, I have to do on the other. So I'm multiplying both sides by negative 6. So then I'm left with m equals whatever 13 times 6 is. Positive times the negative is negative, but I actually need to go off and figure out what 13 times 6 is. And so I might have to go off to the side and show my work. Notice I'm not showing my work here. Whenever we're doing calculations, do it off to the side so it doesn't mess up your equation work. I get negative 78. And I'm done. Okay, things to remember, whatever you do to one side of the equal sign, you must do to the other side. So that's big. Okay, you have 3 equations to solve for independent practice. That's all I got for you guys today. Thanks for watching. If you have any questions, let me know. Critias out.